This is the key to test 3. And number 1, you want to divide uh, this complex number. So remember, the first thing you have to do is to multiply the numerator and denominator by the conjugate of the denominator. So let me go ahead and rewrite this a little bit better. So that's negative 3 divided by 2 plus 5i. And so you don't want that imaginary unit I in the denominator. So you have to multiply both numerator and denominator by the conjugate of the denominator. And so you're going to say times 2 minus 5i. So the conjugate of 2 plus 5i is 2 minus 5i. And remember, what you do to the numerator, you have to do to the denominator. All right, now remember, it does say show work, and you want to write the final answer in the form a plus bi. So what you may want to do first is to rewrite this product as one fraction. So you have negative 3 times 2 minus 5i, and then you have 2 plus 5i times 2 minus 5i. All right, now in the numerator, we're going to go ahead and distribute the negative 3. And when I do that, and let me go ahead and write that here, we get negative 6, and then a negative 3 times a negative 5i is plus 15i. And then remember, in the denominator, these are conjugates. So when you multiply this using FOIL, the outer and the inner will always add up to be 0 because those are conjugates. So for example, if you look at the outer is a negative 10i, the inner is a positive 10i, and so when you add those up, a negative 10i and a positive 10i is 0. So all you have to look at then is just the first, 2 times 2 is 4, and the last. A positive 5i times a negative 5i is a negative 25i squared. All right, so remember that's I squared. I times I is I squared. But then remember, you got to remember the fact that I squared is equal to a negative 1. And so you're going to come back and you're going to substitute negative 1 for I squared. So I get negative 6 plus 15i divided by 4 minus 25 times a negative 1. So the denominator becomes the numerator is negative 6 plus 15i. All of that's being divided by 4. Now, a negative 25 times a negative 1 is a positive 25. And so you get negative 6 plus 15i divided by 29. But in the form a plus bi, you're going to write this as negative 6 29ths plus 15i divided by 29. All right, so that was number 1. Okay, number 2, you want to solve this quadratic equation using the quadratic formula. And so the quadratic formula, remember, is the opposite of b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Before you use the quadratic formula, remember, you need to put this in standard form. So we have to bring the 6x to the other side. We need 0 on this side. So when I do that, I get 2x squared minus 6x plus 7 equals 0. Now make sure you're substituting the correct values for a, b, and c into the formula. So in this case, a is a coefficient of x squared, so that's 2. B is a coefficient of x, so that's negative 6, and c is your constant, which is a positive 7. And so I get, to find the solutions, we're going to say x equal the opposite of b. Well, b is a negative 6, the opposite of a negative 6, a positive 6, plus or minus the square root of b, which is a negative 6 squared. Notice I put that in parentheses, that's important, minus 4 times a, which is 2, times c, which is 7. All of that, make sure you say all of that, is being divided by 2 times a, and remember a is 2. So simplifying the radicand, remember that's a discriminant, but it's also called the radicand. We get 6 plus or minus the square root of negative 6 times itself. Remember, negative 6 in parentheses squared means negative 6 times itself, which is a positive 36. So that should always be positive or 0. That b squared should never be negative. And so a negative 4 times 2 times 7, when you multiply that out, you get a negative 56. All of that is being divided by 4. 36 minus 56, that becomes 6 plus or minus the square root of a negative 20 divided by 4. Now you got to simplify that, so go off to the side and figure out what the square root of 20 is. So to simplify the square root of 20, the largest perfect square that goes into 20 is 4. So that becomes the square root of 4 times the square root of 5. And when I simplify that, that's 2 square root of 5. Also keep in mind that the square root of negative 20, that becomes I square root of 20. So this becomes 6 plus or minus I, and then times 2 square root of 5. All that's being divided by 4. Now I'm going to go ahead and rewrite this in a different way, but also keep in mind that I can reduce the 6 to 2 and to 4. 6, 2, and 4 are all divisible by 2. So when I rewrite this, 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1, so I'll be I square root of 5, divided by, and then 4 divided by 2 is 2. All right? And so I always tend to put the I in front of the square root, so that way if you put it out and back, sometimes you will write it to where it looks like it's under the square root and cannot be under the square root. All right, so that's why we tend to write the I in front of the square root to make sure there's no confusion about where the I is. All right, and so if you want to rewrite this in two different distinct solutions, you can. So you could say x equal 3 plus I square root of 5 divided by 2, comma 3 minus I square root of 2 divided by, square root of 5 divided by 2. Okay? But most students will write it like this, the one that's compact, that plus or minus. All right, so that was number 2. Okay, so then in number 3, you want to solve this equation. And notice that this equation is a radical equation. In particular, notice that it's a square root equation. And so when you solve this square root equation, or any radical equation, you want to get the radical by itself first, and it is in this case. Then the next thing you want to do is you want to raise both sides to a power equal to the index. Well, this is square root, so the index is 2. So I'm going to raise both sides to the second power, just like this. Now notice that on the right hand side you had to put that in parentheses as well. And so we're going to go ahead and simplify this. The square root of 2 minus x raised to the second power is just 2 minus x, equal. When I FOIL this, that's going to be x squared. The out and the inner will be a positive 8x, and then 4 squared is 16. All right, so that's what we get there. Then let's go ahead. Now notice I went from a square root equation to a quadratic equation. And so since I raised both sides to an even power, I may have introduced extraneous solutions. So at the end, I need to check for extraneous solutions. And it does say, show that you check for extraneous solutions. And you all know what I mean by that. Okay, so let's go ahead and put this in standard form. So I'm going to just go ahead and add x to both sides for right now. So I get 2 equals x squared plus 9x plus 16. Then subtract 2. I get 0 equals x squared plus 9x plus 14. And this is factorable. So I'm going to go ahead and let's go ahead and do that here. So I get x squared plus 9x plus 14 equals 0. So I just rewrote it to where the 0 is on the right hand side. So if I factor this, I get x plus 7 times x plus 2 equals 0. And then using a zero factor property, the solutions to this quadratic equation, okay, the quadratic equation is x equal negative 7 and then x equal negative 2. So those are the proposed solutions. Now remember, those are solutions to this quadratic equation. But some of these solutions may be extraneous, meaning they may be false solutions. They may not be a solution to the original. So you got to check. All right, so let's check x equals 7. Negative 7 rather. All right, so go back to the original, and where we see the variable x, you got to substitute negative 7. So I get the square root of 2 minus a negative 7, and I want to see if that's going to equal negative 7 plus 4. All right, well, 2 subtract a negative 7 is a positive 9, so this becomes square root of 9, and On this side, negative 7 plus 4 is a negative 3. Well, remember the square root of 9 is a positive 3, and those are not equal. All right, so what that means is that x equal negative 7 is extraneous. So that solution is not going to work because that's an extraneous solution. All right, so then let's just check the other one now. So now we're going to check x equal negative 2. So you do the same thing. Go to the original problem and you check and see if x equal negative 2 is extraneous or not. And so when I do that, I get the square root of 2 minus a negative 2. And I want to see if that's equal to negative 2 plus 4. Well, 2 subtract negative 2 is a positive 4. So I have the square root of 4 on the left-hand side. And I want to see if that's going to equal negative 2 plus 4, which is 2. And it does because the square root of 4 is 2. And so that is a true statement. So the only solution is x equal negative 2. All right. So this is what you have to show. When it says show, that's what you have to do. You have to show this part here. All right. Number 4. Now number 4, you're given the equation of a circle in general form, and you want to write it in standard form. So remember, this is, and that's supposed to be a plus y squared here. So remember, when writing an equation of a circle in standard form, and it's already in general form, you have to use completing the square. All right, so you're going to do this. You're going to say x squared plus 4x plus some number, and then plus y squared minus 6y plus some number equal, and then we're going to bring this 2 to the other side, this negative 2. So it'll be 2 on the right-hand side. Okay, so remember, what you got to do is figure out, well, what needs to go into those blanks right there. And so you're completing the square on the x's, and you're completing the square on the y's. So to complete the square on the x's, you're going to take half the coefficient of x. So half of 4 is 2. And then once you do that, you're going to square that 2. And when you square that 2, you're going to get 4. So you're going to add 4 to both sides, because remember, what you do to one side, you have to do the other. And do the same thing with the y's. So let me go ahead and put that here. So the coefficient of y is a negative 6. Take half of that, I get negative 3. But then you got to come back and you got to square that negative 3. Notice I put that in parentheses, which becomes a positive 9. So you're going to add 9 to both sides. If you're doing this correctly, this trinomial in both cases needs to be a perfect square trinomial, meaning that when you factor, you'll get a binomial times itself. And it does, because when you factor the x squared plus 4x plus 4, you get x plus 2 squared. And then over here, you get y minus 3 squared. And then equal 2 plus 4 is 6, 6 plus 9 is 15. All right, so that is the answer in standard form. Okay, now we got to find the center. So you wrote it in standard form. Now you're going to find the center. So the center will be negative 2, positive 3. Negative 2, positive 3. And the radius is the square root of this number. So the radius will be the square root of 15. Okay, and that was it. That's all you have to do, number 4. In number 5, you want to solve this system, and it did not tell you what particular method to use. So you could have chosen any method for that one. So you could have used addition, elimination, or you could have used substitution. But I want you to realize that using substitution is probably easier here, because notice that in the first equation, the coefficient of y is 1, and in the second equation, coefficient of x is 1. So substitution is easier to deal with than elimination in this case. And it did not matter which of these you solve for the variable y or the variable x in this case. All right, so let's just go ahead and use the solve for x in the second equation. So we're going to use substitution here. So substitution. And so I'm going to use the second. Some of you may have used the first, does not matter, but I'm going to go ahead and use the second. So in the second, when I get x by itself, I get x equal a negative 4y minus 20. Okay, so when I subtract 4y from both sides, this is what I get. Then what you're going to do next is you're going to take this expression and substitute it into x, because that's what you just solved for in the other equation. And so I get 3 times negative 4y minus 20 plus y equals 6. So 3 times, and I'm substituting this expression into x, that's what you see here, and then plus y equals 6. Now solving this linear equation, notice that this equation that I'm pointing at only has one variable. So let's go ahead and solve for y. So we're going to distribute. So I get negative 12y minus 60 plus y equals 6. And so combining like terms, a negative 12y, a positive y is a negative 11y, minus 60 equals 6. Adding 60 to both sides, this is the linear equation. I get negative 11y equals 66. Divide both sides by negative 11. I get that the y coordinate, or the y value of the solution, is going to be negative 6. 66 divided by 11 is a negative 6. All right, so remember, and the directions did say write as an ordered pair, so you have to indicate this as x comma y. So I found the y value. Now I've got to find x. So we got to find x. Well, you already solved for x right here, right? Now be careful, because you could have made a mistake here. So sometimes, if you're not certain if what you did here was correct, always go back to one of the original equations. But I'm going to go back to this one. So we to find x, you know that x equal negative 4y minus 20, and we just found y, which is negative 6. So this becomes negative 4 times negative 6 minus 20. Negative 4 times negative 6 is a positive 24. 24 minus 20 is 4. And so your solution as an ordered pair will be x, which is 4, and then y, which is negative 6. Okay? And you can always go back and check in the original problem. Remember, we said x is 4, y is negative 6. So look, 12 times 4 is, 3 times 4 is 12. 12 and a negative 6 is a positive 6. X is 4, right? So 4, and then y is negative 6. 4 times negative 6 is 20, negative 24. 4 and a negative 24 is a negative 20. All right? So that was substitution. Now, some of you could have used addition, elimination. So let's go ahead and see what that would have looked like. Now, let's go back to substitution one more time. So notice that in this one, I went to the second equation first. Some of you could have gone to the first, and you would have gotten the same solution. Okay? But let's see what you would have done if you would have done elimination, addition. So addition, elimination. Now remember, when doing addition, elimination, it doesn't matter which variable you eliminate first. All right, x or y. Because of the time issue here, I'm just going to go ahead and eliminate the x. So let's go ahead and eliminate the x. All right, now to do that, if I want to eliminate the x, remember, you got to get the coefficients of x to be opposites. And so first of all, the least common multiple of 3 and 1 is 3. So this already has a 3, this does not, but I need it to be an opposite as well. So I'm going to multiply this equation by negative 3. All right, so if you do the elimination, you're going to say 3x plus y equals 6, and then negative 3 times x plus 4y equal negative 20. All right, and then so that's going to become 3x plus y equals 6. And then when I distribute remember, you got to multiply both sides. So don't forget to multiply this side as well. So when I distribute, I get negative 3x. A negative 3 times positive 4y is a negative 12y. A negative 20 times a negative 3 is a positive 60. Now we're going to add. Now remember, when I add, these are eliminated. Remember, that was the idea, eliminate the x's. So y plus a negative 12y is negative 11y equal, and then 6 plus 60 is 66. Notice I get the same equation that I got here, right? All right. Okay, dividing both sides by negative 11, I get y to be negative 6. So that's the y value. Now we got to find x. To find x, you got to go back to one of these original equations. So let's go back to the first one. So to find x, I'm going to go back to the first one. So I'm rewriting the first one. Wherever I see the variable y, I'm going to substitute negative x. So I get 3x plus negative 6. Whoever saw the variable y, substitute negative 6. So you see that y right here? Negative 6 equal 6. Now I'm going to go ahead and rewrite this a little bit better. So that's 3x minus 6 equals 6, right? Adding 6 to both sides, I get 3x equal 12. Divide both sides by 3. I get x to be 4. All right, and so notice the same value for x here. So the solution will be 4 comma negative 6. Okay, so that's what you did if you eliminated the x. Now, if you eliminate the y, let's see what you would have done if you eliminated the y. So same idea. So the least common multiple of 1 and 4 is 4. And remember, to eliminate the y, you want these to be opposites. So I'm going to go ahead and multiply the first equation, both sides of the first equation, by negative 4. So here's what we can get. We're going to get negative 4 times 3x plus y equal 6 times negative 4. Multiply both sides of the first equation by negative 4. And then the second equation I'm going to keep as it is. All right. And so now this is going to become negative 4 times 3x is a negative 12x. Negative 4 times y is a negative 4y equal, and then 6 times a negative 4 is a negative 24. Second equation, leave as it is, and I get this. Now let's go ahead and add. And when I add, the y's are eliminated, but this time I get negative 12x and x, which is a negative 11x, equal, and then negative 24 and a negative 20 is a negative 44. Divide both sides by negative 11. I get x to be negative 44 divided by negative 11 is a positive 4, which is what we said the x value had to be. Now we got to solve for y. So let's go back to one of those original equations. Let's use the first one again. It doesn't matter. You could use a second. Does not matter. So we're going to solve for y. In place of x, I'm going to substitute 4. Okay? So I get 3 times 4 plus y equal 6. So that's that first equation. So 3x, so x is 4. So I say 3 times 4, which is what you just saw. So I get 12 plus y equals 6. Subtract 12 from both sides. 12 and negative 12 is 0, right? So I get y to be 6 and negative 12 is a negative 6. Right? And that's the y value you're supposed to get. So the solution you're going to say as an ordered pair is 4, negative 6. All right. So that was number 5. Okay, let's look at number 6. So in number 6, you're given this function and you want to find the difference quotient. All right, so the difference quotient formula is this. It's f of x plus h minus f of x divided by h. Now, for many students, it's easier to find this by doing steps. So the first thing we're going to do is we're going to find f of x plus h. So step 1, we're going to find f of x plus h. And so when I do that, wherever we see the variable x in the function f, I'm going to substitute x plus h. So I get negative 3 times x plus h squared plus 7 times x plus h. So again, wherever I saw the variable x, I substitute x plus h. Now let's get rid of the parentheses. Now you got to be careful. Order of operations says I got to square first before I multiply. So we got to do exponents before distributing, before multiplication. So go off to the side, and remember this x plus h times itself, that's what this is. So x plus h times itself. Remember, when I FOIL this, that's x squared. The outer and the inner are the same. So that's plus 2xh. And then the last, h times h, is h squared. So that is this binomial squared. So this becomes negative 3 times x squared plus 2xh plus h squared. And then let's go ahead and distribute the 7 here. So plus 7x plus 7h. Now distribute the negative 3 now. I get the step number 1 to simplify 2. negative 3x squared. Negative 3 times 2xh is a negative 6xh. Negative 3 times h squared is a negative 3h squared. And then plus 7x plus 7h. And none of these terms are like terms, so you're done with step 1. Step 2 now is, okay, so you found this part, now you got to subtract the function from it. So step 2 is to take step 1 and subtract f of x. So step 2 is this part here, f of x plus h minus f of x. So I already found f of x plus h, that's this. I'm going to rewrite that, so that's going to equal negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h. Now you're going to subtract. Now remember, you got to put that in parentheses because you're subtracting all of these terms here. So you're subtracting negative 3x squared plus 7x. See, that's f of x right there. Now get rid of the parentheses. So you're basically adding the opposite of each of these terms. That's what this means. So this becomes negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h. And the opposite of a negative 3x squared is a positive 3x squared. The opposite of a positive 7x is a negative 7x. Now at this point, at the end of step 2, every term that does not have a factor of h, its opposite better be somewhere in that expression, because they're supposed to add up to be 0. Negative 3x squared, positive 3x squared is 0. 7x, negative 7x is 0. So notice that every term that's left, see those 3 terms, they have at least one factor of h. Factor of h, 2 factors of h, and a factor of h. Now, at the next step, you're going to have to divide by h. So at this point, what I would do is I would go ahead and factor out an h from those 3 terms. So this becomes h times negative 6x minus 3h plus 7. Okay, so that is this right here. Now step 3 is to take step 2, because that's the numerator. That's what we just found. So step 3 is where you actually find the difference quotient. So whatever you get at the end of step 3 is your answer. That's the difference quotient for this function. So the numerator is what we have here, step 2. So that's going to be h times negative 6x minus 3h plus 7 divided by h. The h's divide out, and you have your answer, negative 6x minus 3h plus 7. So it says circle the answer, so this will be your answer. So that is a difference quotient, so note the difference quotient, for f of x, which equals negative 3x squared plus 7x, is this right here. So is negative 6x minus 3h plus 7. Okay? All right, so that was number 6. Okay, now number 7, you're given 2 functions, and these are piecewise functions, and you want to find each of these values here. Now notice that this is function f and this is function g, so you got to make sure you're using the correct function as you go along this process. All right, so let's look at part A. So part A says I want to find f of 3. So remember what that means. That means find y when x is 3. So, and it says I got to use a function f. So here's my function f. Now, remember this function f is made up of 2 pieces, 2 parts of 2 parts. So my x value is 3. So I got to use the part where x equal 3 belongs. So notice that x is 3 for this part of the domain. So x is greater than or equal to 2. So that's where 3 belongs. So I'm going to use 3x minus 1. So I'm going to say 3 times 3 minus 1. And then 3 times 3 is 9. So 9 minus 1 is 8. All right, so that's 8 here. Okay. Then I need the next one says you want to find f of 0. So still the same function. You're going to use function f, but this time the x value is 0. So x is 0 in this domain. See, x you're going to use x plus 7 whenever x is less than 2. Well, x is 0, so 0 is less than 2. So you're going to use this one. So for that one, you're going to say 0 plus 7, which is 7. All right. Part C, this time you want to find g of 0. So I got to go to my function g. Notice that this is three pieces here. So you're going to use x squared plus 1 if x is less than 0. You're going to use 5. So g of x is equal to 5 if x is equal to 0. And g of x is equal to 2x if your x value is greater than 0. So this is 0. So that's the only part where you see x equals 0. So you got to say g of 0 then equals 5. All right. There's nothing to substitute as you did these because there's no variable attached to this 5. It's just a constant 5. So if x equals 0, your y value is 5. Now over here, though, you want to, again, so the last two, you're going to use this function g. This time, though, x is negative 2. So x is negative 2 here. See, negative 2 is less than 0, so you're going to use x squared plus 1. So this is become negative 2 squared. So notice the parentheses, negative 2 squared plus 1. Negative 2 times itself is a positive 4, and 4 plus 1 is 5. Okay? And then g of 5, for g of 5, you're going to use this one because 5 is greater than 0. So you're going to use 2x. So that'll be 2 times 5, which is 10. All right, so that was number 7. Okay, let's look at number 8. So in number 8, you want to determine algebraically if this function is even, odd, or neither. And it says make sure you are showing proper work and you explain your reasoning. So remember, when determining if a function is even, odd, or neither, you're going to first of all find f of negative x. That's what you have to find first. And let me go ahead and rewrite this a little bit better so you can see it. So that's f of x equal 5 divided by 2x to the 6 minus 5. All right, so we got to find this first. So that's the first thing you got to do. So where we see the variable x, you're going to substitute negative x. So I only see that part here. So this becomes 5 divided by 2 times negative x to the 6 minus 5. So you have to show that. Then you have to simplify this part here. So we know that negative x raised to an even power becomes a positive x to that power. So this becomes 5 divided by 2x to the 6 minus 5. Now once you do this, you compare, see that's f of negative x now. So now compare f of negative x with f of x. So that's going to be your explanation. So this is your work, and then you're going to explain what you just found. Well, f of negative x is this, right? That's what we just found. F of x was the original function. That's this right here. 5 divided by 2x to the 6 minus 5. And then you compare the two. Notice those are the same. Those are the same functions. So you're going to say since f of negative x equals f of x, then f of x, because that's what you're determining, if this is even, odd, or neither, then f of x, which equals 5 divided by 2x to the 6 minus 5, is an even function. All right, so that's how you had to do it. Okay, so that was number 8. Okay, let's look at number 9. Now, number 9, you're given that this, so you're given the graph of this function right here, and all you're told is what type of symmetry does this have. So based on the graph, is this function symmetrical with respect to the x-axis, the y-axis, the origin, or doesn't have any of these types of symmetry? Well, remember that a graph is symmetrical with the x-axis if a point of the graph you reflected about the x-axis, that point is on the graph as well. And it's not, so you notice that if I reflect anything on this side about the x-axis, there's no graph on this part here. It's on this side. The y-axis, same thing. So reflected about the y-axis, notice you don't see anything on this side. But the origin, so remember, if I pick a point here, let's just say this right here, and I reflected about the origin, so from here and then here, I get a point here. And the same thing here, reflect that about the origin, I get a point on the graph. And the thing about that is that when you think about it, if this is the coordinates x, y, when you reflect it about the origin, it becomes negative x, negative y. All right, and so notice that this is a function that is symmetric with respect to the origin. All right, so the answer there is C. Okay. Now in number 9, so in doing number 9, you have this is your function f, and then you did a transformation to it. So you went from this function to g of x, which looks like this. So you did a transformation, and the question is, which of these transformations did you just happen to do here? Okay, so remember that now remember this is f of x. So notice that f of x, and then you got this part here and this part here. So you got to be careful what each of these means. So notice that this right here means I take my function f, which is this, and I move it up 3 units. But that's not what this is, right? This is what? Down 3 units. I just shifted it down 3 units. So obviously you know right away that it has to be b. This part, so remember these are vertical translations right here. And this is what this is. So you took this, shifted it down. This right here are horizontal translations. So remember that. Those are horizontal, where you're adding, subtracting, and it's in the inside of that parentheses. So that's horizontal translation, and that's not what this is. You didn't slide it to the right or to the left. You went down. So it had to be either A or B, and you know that if it's plus 3, you go up, and if it's minus 3, you go down, and this is obviously what you have. Okay? All right, so that's number 10. Now, number 11. Okay, so number 11, and you can't see this very well. So you're given this function. So here's your parent function right here, f of x equals square root of x. And you're asked, describe the transformations that you would do to this to get this function here. So you want to get g of x, which equals negative 3 square root of x minus 1. Okay? So the first thing you're going to do is you're going to look at how many transformations you have to deal with. So notice you have a negative, you're multiplying by 3, and then you're subtracting 1, right? Okay, so then remember the order. Always do the vertical translation last. Always do that last. That's important. It must be done last. If it's not done last, then there's a possibility that the graph you would end up with is not the graph you need to have. Okay, so keep in mind what this negative right here means. So since the negative is on the outside of my parent function, that's a reflection about the x-axis. Okay, so that part, so right away we can eliminate letter B, right? Because it's not reflected about the y-axis, it's reflected about the x-axis, since it's on the outside of your parent function. If the negative was on the inside, then that would be a reflection about the y-axis. But it's not, it's on the outside, so right away we can eliminate this. So this is eliminated. So that leaves us with A, B, C, and D, because that's the one that only has reflect about the x-axis. Okay, so at least we know we have reflected about the x-axis. So we have that. Then the 3 right here. So we're multiplying by 3. So remember when you multiply by 3, so let me go ahead and remind you about this. So let's just say we had a square root of x. So remember, if a is greater than 1, that is a vertical stretch, okay? And if a is between 0 and 1, that is a horizontal shrink. All right, so when we have this right here, so notice that a is greater than 3, so that's going to be vertical. So you expanded it vertically by a factor of 3. So we know we can eliminate C because that's set horizontally. All right, so just remember that fact right here. Okay, so if a is greater than 1, you have vertical. If a is between 0 and 1, it's a horizontal. Okay, so we can eliminate C because of this right here. So that's eliminated here. It's because of that reflection about the y-axis that was incorrect. Okay, so then it only leaves it with A and B. Well, notice that this -1 here, that's where you're going to shift it down 1, right? Well, so that eliminates D, doesn't it? Because that says down 3 units. So that eliminates that because this is not correct. So then it only leaves us with A. So we expand vertically by a factor of 3. We reflect about the x-axis, and then lastly, we're going to translate down 1 unit. So the answer is A. All right, so that's number 11. Okay, now number 12, you have this function g of x, which is this, okay? And it says part A, you want to graph the parent function. And then part B, you want to describe in words the order of the transformations you would do to obtain this function g. And then you want to graph this function in the coordinate plane. Okay? So let's go ahead and look at that. Okay. So first we're going to do is part A. So that says graph the parent function. So the parent function, so in part A, the parent function is y equal x squared. So remember y equal x squared, if you think about what that looks like, so if x is 0, y is 0, right? If x is 1, 1 squared is 1. If x is negative 1 times negative 1 is a positive 1. X is 2, y is 4. X is negative 2 times negative 2 is a positive 4. When x is 3, y is 9. 3 times 3 is 9. And negative 3, we get 9 as well. So when I graph the parent function, I get this. So I get 0, 0, 1, 1, 2, 4, 3, 9, right? Same thing here. Negative 1, 1, negative 2, 4, negative 3, 9. And so now I get this, something like this, on this side as well. Okay, so that's your parent function. That's part A. So that's what you have to do. Y equal x squared. Okay, now, part B says describe in words the order of the transformations you would do to obtain the graph of g of x. So keep in mind the vertical translation has to be done last. That has to be done last. Because if you do the reflection, at the end, you actually get a different graph. Okay? All right. So first we're going to do is we're going to do the reflection about the x-axis. So you're going to say part B. You're going to say first take y equal x squared, which is a parent function, and reflect about the x-axis. And so when we do that, and we'll just kind of explain that here. So when you do that, you're taking each of these points and reflecting about the x-axis, right? So you're going to end up, so basically what you're graphing now, so you will end up graphing this function, y equal negative x squared. So that's what you're going to end up graphing. All right, so let's do that. So the point 1, 1 becomes this point here, right? 0, 0 stays 0, 0. Negative 1, 1 becomes negative 1, negative 1, and so on. Okay? 2, 4 becomes 2, negative 4. Negative 2, 4 becomes negative 2, negative 4. All right, and so on. So it looks something like this. Okay, so I want you to notice that what we just graphed here, was y equal negative x squared. Now, next thing you're going to do, so second, what you're going to do is you're going to take what you just graphed and you're going to shift it to the, now we're going to do this part here. So that's where you shift it to the right 4 units. So now you're going to say shift, so most of you said this, shift to the right 4 units. But remember, when you shift to the right 4 units, you're actually shifting this. So you end up with the graph of this, y equal negative, in parentheses, x minus 4 squared. Okay, so now what we're going to end up with will be this part here. So this becomes, so you're shifting every point to the right. So go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. Something like that. Okay, so what I've graphed here, I could be a little bit better right here. But this is now y equal negative in parentheses x minus 4 squared. And now what you're going to do is you're going to do the vertical translation. So now the third thing you're going to do is you're going to say translate or shift up, translate up 7 units. Now just keep in mind what you're actually translating up 7 units. You're translating this up 7 units. So you end up with y equal negative x minus 4 squared plus 7, which is your function g of x. So all you do now is just take each of these points and shift it up 7 units. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. Something like that. And there's your graph. Okay? I could do this a little bit better. I didn't go through that point. All right, so that is g of x. So this right here is g of x. So if I go ahead and just kind of highlight this, this is g of x right here. Okay? All right, that's g of x. All right, so notice I did the reflection. So I took the parent function, I reflected about the x-axis, then I shifted to the right 4 units, and then I shifted it up 7 units. And that's what this part right here says. Okay? All right, so that was number 12. Okay, number 13. So you're given two functions, f of x and g of x, and you want to find g of 3 plus f of 1 for part A. And for part B, you want to find f of 5x plus 1. So let's look at part A. So in part A, you want to find g of 3 plus f of 1. Well, let's go off to the side and figure each one of these out. So g of 3 means I go to my function g, which is this one, and wherever you see the variable x, I substitute 3. So remember, g of x is this, okay, negative 6x squared plus 5x. And then, so g of 3 then would be negative 6 times 3 squared plus 5 times 3, right? And so 3 squared is 9, and then 9 times a negative 6 is a negative 54, and then negative 54 plus 15 is what we have. 5 times 3 is 15. So a negative 54 plus 15 is a negative 39. So that goes here. So that just found g of 3. Now, we got to find f of 1. So f of 1, then I go to my function f. So let me go ahead and rewrite this as f of x. So f of x is 3x minus 7. So now to find f of 1, where we see the variable x, I substitute 1. So it becomes 3 times 1 minus 7. 3 times 1 is 3. 3 minus 7 is a negative 4, right? All right, so that becomes negative 39 plus a negative 4. And so negative 39 plus a negative 4 is a negative, what's that, 43? So it becomes negative 43. All right, so that was part A. Now in part B, oh, and by the way, remember our discussion previously that whenever you are evaluating a function at a number, you will end up with a numerical value. Now in this one, you see evaluating the function f at a variable expression, so you can end up most likely with a variable expression. So let's look at part B. So in part B, you want to find f of 5x plus 1. So this time I go to my function f. Remember, this is your function f right here. So 3x minus 7. And wherever we see the variable x, I'm going to substitute, wherever we see the variable x, I'm going to substitute 5x plus 1. So it becomes 3 times, in parentheses, 5x plus 1 minus 7, right? And then distribute. I get 3 times 5x is 15x. 3 times 1 is 3 minus 7. Combine like terms. A negative 3, positive 3 and negative 7 is a negative 4. So that is f of 5x plus 1. So that becomes 15x minus 4. All right, so that's number 13. Number 14. So you're given this function f of x. This is an arrow. This is a closed circle. and you want to find f of negative 4. All right, so remember, to find f of negative 4, you're asking yourself, what's the y value when x is negative 4? So when x is negative 4, let me go ahead and use a ruler. When x is negative 4, all right, so I go here, and then notice that this is the point of the graph right here, where x is negative 4. And so when x is negative 4, my y value is 3. So your answer, though, remember, this says what's f of negative 4. So make sure you understand what that means. That means what's the y value when x is negative 4? Well, the y value when x is negative 4 is 3. So 3 goes here, only 3. What is the zero of the function? So another word for zero is the x-intercept. So basically, when you find the zero of the function, you're also finding, so that's one way to think about the x-intercept. But the zero of the function, when you find the zero of the function, you ask yourself, what is y? What is y when x equals 0? So x-intercept, remember the x-intercepts I'm sorry, let me rephrase that. Finding the zero of the function is the x-intercept. So what's the y value when y is 0? Excuse me. When y is 0. When y is 0, not x. Sorry. So the x-intercept, remember, is when y is 0. So no matter where you are on the x-axis, that's where your y value is 0. So notice that my x-intercept's here. So the zero of the function right here is negative 2. Negative 2. So that's where the y value is 0. Part C, what is the domain of the function? So remember, the domain is the set of x coordinates. You go from left to right, correct? So notice that's an arrow, so that's pointing, so it's kind of like moving this ruler to the left. So you're going from negative infinity to this x value here. And notice that that's the y-axis, so the x value is 0 right here. So you're going from negative infinity to 0 with a bracket, okay? Because that's a closed circle. Then the range, you go from bottom up along the y-axis. That's a set of y coordinates. So notice you start here at y equal negative 3, at negative 3. And then you keep on going. See that arrow, so you keep on going up. So you're going from negative 3 all the way to infinity. So it'll be bracket negative 3 to infinity, okay? All right, so make sure you understand what a 0 is. So when you ask to find the zeros, and you're gonna see this again, we'll talk about polynomials, but one way you can think about it is the x-intercept. So what's the x-intercept? Because remember, for the x-intercept, my y value is 0. But it also means what is the what is x? What is x when y is 0? Okay, so what is x when y is 0? So when y is 0, that's along your x-axis. So x when y is 0 here, my x value is negative 2. Okay, all right. So make sure you fix this right here. So x-intercept is what is x when y is 0. Okay. All right. So that was number 14. Number 15. Okay. So here you're looking at combination of functions right here. So remember f plus g at 2. So if you look at part A, f plus g at 2 means the same thing as f of 2 plus g of 2. That's what that means. So now we got to go find what f of 2 is. So here's my function f and here's my function g, right? And so to find f of 2, I'm going to go ahead and do that here. So f of 2, you go to your function f, and where we see the variable x, you substitute 2. So that becomes 2 times 2 squared minus 3 times 2 plus 1. All right, so we saw the variable x, you substitute 2. Well, you do the exponent first. 2 times 2 is 4. 4 times 2 is 8. Negative 3 minus times 2 is negative 6, and then plus 1. 8 minus 6 is 2. 2 plus 1 is 3. So f of 2 is 3. Plus, and then you do the same thing for g of 2. So this time, there you go to your function g. So g of 2 this time, again, go to your function g. You get 2 times 2 plus 3. 2 times 2 is 4. 4 plus 3 is 7. So it becomes 3 plus 7, which is 10. So part A, the answer is 10. Now in part B, you want to find f minus g at x. So remember what that means. By definition, that means f of x minus g of x. All right. So f of x is this. So this is f of x, 2x squared minus 3x plus 1. But be careful, you're subtracting g of x. So you're subtracting all of this. So you got to put that in parentheses. So g of x is 2x plus 3. Now getting rid of the parentheses, so you're taking the opposite of each of these terms, you get 2x squared minus 3x plus 1, and then the opposite of 2x is a negative 2x, and the opposite of a positive 3 is a negative 3. Combining like terms, and let's go ahead and put this in descending order. I get 2x squared. A negative 3x and a negative 2x is a negative 5x. 1 and a negative 3 is a negative 2. So that is the answer for f minus g at x. So that's 2x squared minus 5x minus 2. Okay, and that was it. That was test 3, and so that was the key. That was the key to test 3.